All right, so you guys have actually learned 7.1 through 7.4, which means we're going to spend a little bit of time reviewing because that is the last section talking about different equations. So basically, today is very similar to yesterday. Your homework is going to be this quiz that will be posted on Google Classroom. So you will be required to do numbers 1 through 14. However, for your notes, I am going to guide you through not all of them, but some of these questions. So your notes will be doing some of these questions with me. Then your homework is to finish all of the ones that I do not do. So let's get started. So hopefully you have this in front of you. You either could have printed it out or you can be doing it on a separate piece of paper with the screenshot in front of you. So I will be referencing these questions, so I would like you to have this in front of you. So if I say I'm doing number 7, you know what it's asking for number 7 and you know what number 7 is. So the first one I want to talk about is number 1. So again, please have this out in front of you. Here are the notes I will be going over. So for number 1, the only thing I just want to make sure is with when we're talking about subtraction, we're being very careful. So it says write the one-word sentence as an equation. So I will add my equal sign. An equation has an equal sign, and I will write it using my numerical symbol. So a number x, so I'm thinking of x. Now I have to think about what it's saying. It says a number x decreased by 3. So x is being decreased meaning minus 3. So x minus 3, it says is 5. Is 5. And remember, whenever you hear is, you can put your equal sign. Is means equals. So then you guys will do number 2 on your own. Let's go over, so solve the equation and check your solution. I want to go over number 5 with you. So number 5 is 8 equals 4 times W divided by 3. And so right now I'm thinking, where's my variable? When it says solve the equation, that means I want to know what is W. I'm solving for W. So I found here's W, and I think about what is being done to W. Well, right now I could think about this as 8 is equal to 4/3 times W, because this is a nice easy check of, oh, if W is being multiplied by a 4/3, I can multiply by my reciprocal, which would be 3/4, because 12/12 just equals 1, so that will cancel itself out. So I multiply this side by 3/4, I multiply this side by 3/4. This cancels out. Here I think 3 times 8 is 24. 24 divided by 4 is 6. So I'm left with 6 is equal to, I bring my W down, W. So W is equal to 6. And that is my answer. Now, the other option I could have done is if I have 8 is equal to 4W/3, I can say I'm going to do the opposite to W. And right now W is being divided by a 3, so I'll multiply by a 3. And the W is being multiplied by a 4, so I'll divide by a 4. And do you see how that is the same thing that I did over here? I multiplied by the reciprocal. That's essentially what you're doing to each side regardless. All right, let's do number 7 together. So for number 7, again, I want a yes or no. Is the ordered pair a solution? So I'm given an equation like y equals 6x, and then you're given an ordered pair, 3, 24. And remember, your ordered pair, this is always going to go x then y, x then y. So I know that 3 is x and 24 is y. So now I plug these in and I see if it will be true. Y is 24, so 24 is equal to 6 times x is 3. 6 times 3 is 18, so I think is 24 equal to 18? No. So my answer is no. These x and y values would not be a solution to that equation. All right, so then let's move on to number 9. So I'm looking at number 9, and it's saying here I want to write and graph an equation in 2 variables that shows the relationship between the time and the distance traveled. So you guys just read time and distance. What formula does that make you think of? Your distance formula. So remember, in your notes, you should have right away, I'm thinking my distance will always equal my rate times my time. My rate times my time. That is your distance formula. Now, my r, that's equal to my rate. And for example number 9, my rate is I rise 4 feet, so I have feet every per second. And then I fill in my numbers, it's 4 feet per 9 seconds. Remember, this is your rate. This is a ratio. Goes back to our chapter on ratios. So what I can do is plug in. This tells me r is going to be equal to 4 over 9. That is my rate. So I get my distance will be equal to 4 over 9, depending on how many seconds, how much time I am, in this case, using my different, my machine to go up. So here's my equation with 2 different variables. So I have that first part is complete. And now I want to graph it. Well, to graph this, I need ordered pairs. So what I can do is say, here, I want to know what is my independent variable and dependent variable, because I'll have my independent variable, I'll have my equation, and then I'll have my dependent variable, and then here's my ordered pair. So I want to think, my independent variable, this is going to be my time. However much time I have, well, my dependent variable is my distance. The distance that I go will depend on my time. So here my ordered pair is t comma d. Same thing as x comma y, because t is my independent, y is my dependent. And then my equation is d equals 4/9 times t. So let's go ahead and plug in some different time values to get different ordered pairs. So let's say that we plug in, if I go for my time, I can say I plug in 1 second. Or really, what would actually be a smart, what times 4/9 would give me a nice number? Let's try 9 seconds. What if I plug in 9 seconds? Well, if I plug in t as 9, this will equal, my distance will equal 4 over 9 times 9. Well, my 9's will cancel out, so my distance will equal 4. So here's my first ordered pair of 9, 4. What's maybe another strategic time value that we can plug in? Think about another strategic time value that we can plug in. Well, what if I plug in 18? Well, now my distance, for 18 seconds, my distance is equal to 4/9 times 18. And here I can cross reduce. I know that 18 and 9 goes into 9 once, 9 goes into 18 twice. Remember cross reducing. So distance is equal to 4 times 2. Distance is equal to 8. So my next ordered pair is 18, 8. And let's do one more. Well, hopefully you can kind of see the pattern I'm going in, this pattern. Let's go with 27. So now my distance is equal to 4 over 9 times 27. Or I can think of the same thing, 27 over 1. I can cross reduce. I know that 9 goes into 9 once, and 9 goes into 27 3 times. So now I have my distance is equal to 4 times 3, which is 12 over 1, or just 12. So my ordered pair is 27 over 12. And I have at least 3 points is usually kind of the standard. Get at least 3 ordered pairs, and then you can go ahead and graph it. So here's my graph. I'm comparing my time, which is in seconds, to my distance. And so here I'll set it up. My time, I'm going to go by 9, 18, 27. We can go by nines. So this will be, here's 9, 18, 27. Remember, kind of like a timeline. I also could have said and gone by threes. 3, 6, 9, 12, 15, 18. So you can also kind of do that. But as long as I have 9 seconds, 18, and 27. And then I want to go 4, 8, 12. So I'll go by fours. So here's 4, 8, 12. So I know that at 9 seconds, I am at 4 feet. So I go over, here's 9, 4. Then I have 18, 8. So 18, I go up to 8. And then 27, 12. Go over to 27, go up 12. And there's my line. And it should go straight. At 0 seconds, you haven't gone anywhere. So there's my graph. So do that same thing for number 10. You're moving 10 100 feet every 10 seconds. Again, you can always find a sorry guys, my video cut out on that last problem, but all I was really going to be saying was you can always find the unit rate as well to help you graph. Anyways, let's move on. The next one I'm going to do is, let's do number 13 together because there's a lot of different parts in number 13. So let's go ahead and look and read it together. If I'm looking at 13, you'll see it's shopping, and there's two different pictures, images that are going to provide you with information you need to know. So I'm shopping. So I don't know if you guys have ever gone to the farmer's market. I know it's a big thing for all of you middle schoolers to go to the Hermosa Beach Farmer's Market. I've actually never been. So maybe we can all meet up over summer or something. So you're at the farmer's market and you buy 4 pounds of tomatoes. So if tomatoes are $3 a pound, $3 per pound, and I buy 4 pounds of them, think about, well, how much money did I spend on tomatoes? And I buy 2 pounds of sweet potatoes. So then I have 2 pounds, $2 per pound. I buy 2 pounds of them. How much money do I spend on sweet potatoes? Now here's where you have to pay close attention. I spent a certain amount of money. I spent 80% of the money in my wallet. So what it's saying is you go to the farmer's market with a certain amount of money. We don't know how much money you originally had, and you spent a certain amount of money, which happened to be 80% of your wallet. So this is asking, write and solve an equation to find out how much money is in your wallet before you went to the farmer's market, before you paid for all of the sweet potatoes and tomatoes. So there's a lot of different parts here. Let's kind of break it down and go together step by step. So my first step is I want to know, well, how much money did I spend? So I bought some tomatoes. And then I bought, I'm just going to say SP for sweet potatoes. Now I bought I bought 4 pounds of potatoes. It's $3 per pound, so 4 times 3 is 12. Or I can say if it's $3, throwback to ratios, $3 per pound, per 1 pound, that will equal, for 4 pounds, that will equal how much? Well, 1 times 4 is 4, so 3 times 4 is 12. So basically I can say I spent $12 on tomatoes for 4 pounds. So I have $12 for tomatoes. For sweet potatoes, I spent, I think I see what I did. For sweet potatoes, I can do the same thing. It's $2 per 1 pound. And I bought 2 pounds. So I multiply denominator and numerator by 2, which gives me, I spent $4 on 2 pounds of potatoes. Again, you can just do this in your head if that works for you as well. Some of you probably were able to do that. So I spent $4 on my sweet potatoes. So altogether, how much money did I spend? Well, 12 plus 4 is 16. So I spent $16. So now I have to think about, what am I trying to solve for? I want to know, okay, I spent $16, but how much money did I go to the farmer's market with? Well, I know that $16 is equal to, it says 80% of the money in my wallet. So I spent $16. 16 is equal to 80% of the money in my wallet. And I don't know how much money was originally in my wallet, so I can use, let's just use W to represent this unknown amount that was in my wallet. So now let's just simplify from here. Basically what I'm doing is I now have one variable, so I can solve for my one variable. Well, let's rewrite this into simpler terms. I can say that 16 is equal to, and do you remember, how can I write 80%? There's sort of two different ways. Let's go to we have two different ways. I can either write this as 80 over 100 times W, or the other way of 80%, I can say 16 is equal to 80 hundredths is the same thing times W. So from here, depending on which way you wanted to solve it, I could say, well, W is being multiplied by this fraction, so I can multiply here by the reciprocal to undo it, to cancel it out. So I'll say that this is 100 over 80, and I multiply it, because this over this will equal 1, so basically this just cancels out and leaves me with 1W. But what I do to one side, I have to do to the other, so I get 100 over 80 times 16. And here I can do a lot of cross-reducing. I can think, well, 100 over 80, what can I simplify that to? Well, I can simplify it by crossing off a 0, and then what can I simplify 10 over 8 to? 5 over 4. 5 over 4, so 5/4 times 16. Well, if I do 5 times 16, that's 80. 80 over 4 is equal to W, or I can simplify it further and say W is equal to 80 divided by 4. Well, 8 divided by 4 is 2. Add on my 0, W equals 20. So I could say that I had $20. I spent 80% of my $20, meaning I spent 80% was that 16. Over here, I can say same problem, just a different way of solving it. W is being multiplied by 80 hundredths, so I can divide by 80 hundredths, divide by 80 hundredths. So then this will cancel out. I'm left with W. W was equal to 16 divided by 80 hundredths. I move my decimal over 1, 2 place. So then I move this over 1, 2 place. So then I can say 80, and then I have 1600. And if I solve this, I'll end up getting the same answer of 20. So in this case, it will still equal, W will equal $20. So good luck with the rest of your problems. Let me know if you have any questions. I'll be on Google Hangouts and Zoom and everything today from 8 to 3. So good luck and keep it up. I will talk to you guys soon.